Hello there. Today we'll be doing kth largest elements in array. So in this particular problem, what we need to do here is we're gonna grab a list of numbers and we need to find the kth largest item. So in this particular case, we're looking at a 5 because the largest item is a 6 and the second largest is a 5. So some solutions that we can think of is sorting, which takes n log n time to sort the entire array, but we can do a little bit better if we use a heap and do O of n plus O of k plus O of k log n. The reason why we need to do k log n after creating the heap is because we need to find k items in our when we move each item out of a heap. It takes log n time, and so this is not O of n time complexity. To get the O of n time complexity, we need a quick select function, and this allows us to basically cut these items in half. So basically, after a first search, we have half these numbers left, and after the next search, we have half those numbers left, and at the last search, we have our last number left, and that must be our number. But it could end even earlier. Let me show you how quick select works. So in quick select, what we do is that we find a pivot point or pivot value, and we determine that pivot point where it exists. So right here, this is our pivot point, and this is our I value. So and I value, we think index. So 0, 1, 2, 3, 4, and 5. So our kth item is going to be, so let's say our second largest item is going to be the fourth item in this, I think, because kth largest is equal to the length of nums minus k, so from the n side. So kth largest in this case is that we have 6 numbers minus 2, which is equal to 4. So our kth largest is equal to 4. At the 4 index, we would found our kth largest value. So what happens here is we look for that particular pivot point of 4. So everything smaller than 4 is going to go behind 4. So we keep moving our pivot point forward, and because it is less than 3, and we swap I and pivot point every time they're equal, in less than or equal to 4. And once we get to the 5, we keep the pivot point at 5, this particular item 5, and we keep moving the I forward until we reach the end, and now we can swap the pivot point with the pivot with the pivot value, the point the location of the pivot value. And with that swap, you will see that all the values on the left side of the 4 is smaller than the pivot point, and every value on the right side is bigger. So with that, we can eliminate half the values that we don't need to look for anymore. And because k is going to be larger than, kth largest is larger than our pivot point, we're going to only search in this half. If it's less than, we're going to search in this half. If it's equal to, we'll return it. So let me just type that out. So if pivot point is equal to 4 equal to kth largest, we're going to return num at kth largest. Otherwise, if it's greater than kth largest, then we need to look the left half. We'll return quick select of the left half, which is going to be left and the pivot point -1. If it is larger, if the pivot point is smaller instead, right, then that means we need to check the right side. And so we need to do a +1, and we're checking the right side. And with that, we can return our answer, and that's it. That's the end of this particular problem, and we can do this in O of n time. However, sometimes, unfortunately speaking, we pick the wrong spot at the end, and it's like a 6, and then 5, 4, 3, 2, 1, right? You can imagine that we do run this O of n time, so 1, 2, 3, 4, 5, 6, and we look at the 6 and everything is smaller. We look at the 5 and everything is smaller. Look at the 4, everything is smaller, and so on and so forth. That would be n squared time. Okay, let's just check. Let's get this problem started and let's complete this. So kth largest equal to length of nums minus k. Oh, not 4, k. So we're going to define quick select now. So we need a left and right pointer. And we're gonna do is a pivot value is going to be nums at r, and the pivot point is equal to L right now. So for I in range from left to right, what we're gonna do is we're going to, if the nums at I is less than or equal to nums at the pivot value, we're going to swap the I and the nums at the pivot point. So make sure all the smaller items go to the left side of the pivot point and all the bigger items go to the right side. With that done, we will now swap the pivot point and our pivot value, which is our rightmost value. Pivot, pivot. Okay, so with that, we can now return if a pivot point is equal to kth largest, then we can return our nums at the kth largest because the pivot point and the kth largest are equal. Else if the pivot point is greater than the kth largest, that means we return the quick select of the left side, so pivot point -1, else we're going to return the right side. As you can see, the pivot point was too small, so it must be on the right side. Okay, with that, we can just run quick select. Between 0 and the length of nums -1. And with that, I believe that we have solved this problem, except that we have a syntax problem right now. Invalid syntax. Alright, it has been accepted, and let's send this in. Right, so for those who are curious about, oh shoot, it's wrong. So right, our pivot point did not increase. All right, great. It is mighty slow. This is because the O of n time is n squared rather than O of n, but on average it's O of n. So to do this with heap, it's pretty easy and it's a lot less technical. So let's check that out too. So we're gonna heapify our nums. And we're gonna have our smallest items. So we're gonna get rid of the k items. So k largest items. So k equals length nums minus k. So all the small items are gonna disappear. And so while k is greater than 0, we're gonna do a heap q dot heap pop of our nums and k minus equals 1. And once we're done with that, we can return heap q heap pop at nums. And with that, this is going to be our k log n solution, and it is much much faster and also much more convenient option. But I think this is as fast as we can get. So if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.